Alright guys, welcome back. Sorry about the audio issues for the first version of this video, but let's talk what is power. Alright, we'll show this at the beginning of class, so you get a freebie if you didn't do your homework last night. You can quickly do it right now, or at least you didn't do the video portion. Remember, if there's ever any technical issues, don't worry about it. Don't sweat it. Come to class, write me a note, have your mom sign it, have one of the flex teachers let me know. No worries, technical issues are never your fault. Alright, let's talk about power. What is power? Power is the rate at which work is done. Now, a rate tells me how fast or how quickly something is happening. When I talk about speed or velocity, those are rates at how quickly my position is changing. Acceleration is a rate, how quickly my velocity is changing. Right? The minimum wage is a rate. It tells me how many dollars I make per hour. So it's telling me how much per time when I have a rate. Now power, this concept of power is going to depend on two factors. What are the two factors? The amount of work that's done. Okay, so we're measuring work, and we're measuring how quickly that work is done. So the second factor is time. So it's the amount of work done in a certain amount of time. So when we talk about powerful machines, what are powerful machines going to do? Well, they have three options. They can either increase the amount of work you can get done, or they can decrease the amount of time it takes to do that work, or they can do both. Those would be the most powerful machines, right? So we need to have a comparison, a measurement of how much work gets done in a standard amount of time. And so therefore we can compare two machines doing two different jobs, right? So how do we calculate that? When we want to calculate something, we need an equation. We need a standardized way of determining a value. We want to go from qualitative, saying, yeah, that looks like a lot more work, to quantitative, giving me a number. How much more work is it doing in a given time? So our equation for power is work done over the time that it takes. Power equals work over time. Now, what units are we going to use? The international unit is a watt, after scientists who did most of the work with early engines and power. And we know that a watt is equal to a joule per second, because our units for work are joules, our units for time are seconds. So it's a joule per second. Cool? All right, if you get joules per second, we can convert to watts. We get watts, we can convert to joules per second. They're the same thing. Two names for the same quantity. Now there's also the historical unit of horsepower. Okay? Before we got into all this physical analysis, people would say, oh, well, that's a 3-horse job. Well, that's a 6-horse job, when they were talking about plowing the fields. All right? Horse is a very powerful beast, and sometimes you needed 1 horse, sometimes you needed 2, sometimes you needed 4. Depending on the work that needed to be done, you need different numbers of horses. But that's not very standard, is it? Because 1 horse could be more powerful than another. You could have, an Arabian horse versus a Clydesdale. All right? So the historical units, and you see this still a lot with car engines. Oh, this has 700 horsepower, 550 horsepower. Those are historical units, and they're ones that people are used to, especially with car engines. But in physics, we're going to go with the international standard of watts, or kilowatts, which means 1,000 watts, or megawatts, which means 1,000,000 watts, that whole SI system. All right, make sure you got all the words on the slide, wrote down something you heard, something you're curious about, then flip the sheet over and do your reading. See you in